Cast is now starting. All attendees are in listen-only mode.
We're going, people. Here we go. Jonathan, can you hear us okay?
Yeah, but I don't think you can hear me. I think my system's one that just caused the problem.
No,
Yeah, it's a little intermittent here.
we can hear you now.
Yep. All right, I'm starting the broadcast,
My
everybody.
system's...
Here we go. Hi, everybody. This is Greg with Mitsubishi. We're going to wait a few more minutes here and then start right on time. So just hang on.
You're back, Jonathan. Can you hear us?
Yeah, sorry for the technical difficulties there. It freaked out on me.
Okay, no problem. We can hear you fine now.
Ken and Jonathan, I think we're live, so just be aware.
Yep. All right, we're almost there, Greg and Jonathan. Can't hear you, Greg.
Yep, how about now?
Yeah, okay.
Good deal. Jonathan, are you online here?
I should be. You guys should still be able to hear me now, right?
Yeah.
Yep, you're perfect. Sounds good.
Perfect.
All right, I think it's noon. Everybody ready to roll? We'll go ahead and get started here.
Let's start.
Jonathan, do you want to go ahead and kick us off?
Sure. I want to thank everybody for attending the first Lunch and Learn here from the Tri-Cities Home Builders Association. We are located in southeastern Washington. Our goal is to set forth an education for a Lunch and Learn at least once a month. And so our first opening act, we have the wonderful Greg with Mitsubishi, and he's going to take it from here.
All right.
Good deal.
Actually, I can jump in first. My name is Ken Johnson. I'm the Senior Manager for Mitsubishi Electric's Performance Construction Team for the Western region. And I've got a couple of reps. I cover California and Nevada. I've got another rep that covers Colorado, Utah, and Arizona. And then Greg Davenport covers the Pacific Northwest for us. And we call on builders, architects, raters, installers, anyone who's involved in the new construction process to try to raise awareness of the benefits of variable capacity heat pumps. So thanks, as Jonathan said, thanks to all of you for joining today. We've got a good crowd and a lot of interest in this. And Washington State has made some major upgrades to the code. And Greg will walk us through some of that. So why don't I turn it over to you, Greg?
Thanks, Ken. I know some of you on the line here. For those of you who don't know me, my name is Greg Davenport. I'm on the Mitsubishi Performance Construction Team. 2007 to 2013, I worked on a Energy Star was a joint utility Energy Star lighting program here in the Seattle area for all 4 of the major utilities around Puget Sound. That came to an end when the 2012 code changed. So I've been through some of the big code changes before. That one was a job-ending code change for me. I then moved over to ClearResult and worked for about a year on the NEA High Performance Home program that some of you may know as the Performance Path now. That kind of grew up into Performance Path that a lot of the utilities are running incentive programs on. Took off, went to Asia for about a year, came back, and then I've been with Mitsubishi for about 5 years now, almost 5 years, working on the performance construction team, where, as Ken said, we work with high performance builders and other allies like Jonathan to help improve energy efficiency in home building. We've got a lot to cover today. If you have questions, feel free to put them in the chat box. Ken and Jonathan are going to monitor the chat box. If there are any burning questions that are unclear on material that I've covered, they may ask me to talk a little more about it. Otherwise, we're going to hold questions till the end. Presentation should go 55 minutes to an hour. And then afterwards, we'll open it up for Q&A and try and cover the questions in the chat box. And we may even unmute people if we need to do some more Q&A. So here we go. Today, we're going to talk about the new Washington State Energy Code. You can see on the bottom here, it says effective July 1, 2020. Most of you probably know that was extended a couple times, but it went live on February 1 of this year. And we're not going to go through all the code issues. We're really just going to summarize some of the mechanical stuff. In particular, we're going to talk about what's going to be the most cost-effective pathways for builders. We're going to focus strictly on residential, but we will cover both single-family residential and low-rise multifamily here. This is not going to cover everything. For the last word in all of this, you should look at the code. If you go to the handouts button on here, I did attach the full code package, so you can pull it down if you don't already have it. Also, local jurisdictions and or the state of Washington always have the last word on this. So when you get into sticky stuff you're unclear about, they are your best resource. I saw when this all started about a year ago that they're really pushing builders towards energy efficient heat pumps and mini split systems. So I knew there'd be a lot of questions on this. I've been highly involved in this, and this is probably about the 15th time I presented this training session. Made a few updates on it, but we're trying to help everybody understand this and find the easy way to meet the new code. And what you're gonna see in here is high efficiency heat pumps and mini split systems are going to become pretty popular in Washington State. Okay. This is a great slide. We use this in a lot of our training presentations. We just updated this number from 9% to 12% for the North American market. It is climbing rapidly, but in most of the rest of the world, variable capacity heat pumps, there's a couple words I'm going to use today. Variable capacity heat pumps is probably the best way to describe a high efficiency heat pump system. Many of us in the Northwest also call them ductless heat pumps, but they've come a long ways. We also sometimes use the word mini splits, and just think high efficiency heat pumps, and we'll talk about high efficiency central heat pumps too. So the North American market over the next 10 to 20 years, I think will get caught up with the rest of the world, and you'll see this be the dominant technology very soon. Certainly in Washington State, we're heading that direction, probably ahead of most of the rest of the country. Some of the people on the line here, I think, are highly involved in the code cycles. For some of this, it may be a little bit new. IECC is an international group that puts out building standards and codes, and every 3 years, they roll out a new code cycle. Different states adopt it at different times. Here you can see the HERS score, which was set to 2006 IECC as the baseline. And you can see that HERS score, think of it like miles per gallon when you go to shop for a car, but we have cut that in about half with IECC 2018. The Washington State Energy Code, I would say, is a little bit ahead of IECC 2018. And I think it's a fair statement to say that our current energy code is dangerously close to the DOE Zero Energy Ready specification. And the raters around Washington State use Built Green is really one of the best certifications here. There's a few builders that do Energy Star or Washington State Built Green. Those of us who are in Washington and even the Pacific Northwest, many of us are not aware that we have really advanced codes here, and every Washington State home, including the code built homes, are high performance homes compared to the rest of the country. Ken and I work on a team where we see homes built all across the country, and Ken and I even have conversations from time to time about Washington code compared to California code, which is where he's from. And I actually think that the Washington codes may be the most progressive in terms of energy efficiency and sustainability around the country. And I think all of us who are in the home building industry here in Washington should be really proud of what we're doing. This is a big deal, and builders have to get it. HVAC contractors really need to get this. But as you look at this table here, you can see 2006 IECC in the left column, 2018 IECC, DOE Zero Energy Ready. And I think that DOE Zero Energy Ready column is a pretty close approximation for Washington State. But heating and cooling loads are getting lower and lower as we build better and better homes. So you can't have an HVAC contractor that continues to put 4 and 5 ton gas furnaces in every house. They're just grossly oversized, and it's not going to work anymore. It's a great opportunity, but people need to change their thinking here. And you can see on the left 2 columns, passive heating and passive cooling. What we're seeing in Washington State, Oregon, and a lot of other places is we have historically been heating dominant, where the heating loads have significantly exceeded the cooling loads. Because heating loads are coming down a lot relative to cooling loads, we're seeing more and more homes where the heating and cooling loads are getting very close. Some of the projects I work on now, we have cooling loads that are the same or slightly higher than the heating loads. I've got a small multifamily project down in Oregon right now, Portland area, where the heating loads, these are low-rise multifamily. Heating loads are 6,000 to 8,000 BTU, and the cooling loads are 9,000 to 10,000 BTU. The other thing that's super important, and this is why the variable capacity heat pump systems really make sense, is they come in a lot of different size options, so you can pick a right size system for your house. A lot of the traditional unitary manufacturers make, 3, 4, and 5 ton systems, and don't make so many of the smaller size systems. So that's something we all need to shift on. Under the new Washington State Code, if you have a passive certified home, you're automatically going to meet the code here. There are not a lot of passive builders out there right now, but it's interesting. And you'll see some things referenced in the tables that are coming up that are basically passive level, but they don't call it out as passive. And passive is really the pinnacle of how builders build. It's, 1/4 of 1% at most. There's probably 40 or 50 passive projects in Washington State a year that get certified. There's a lot of near passive stuff or non-certified passive stuff. So I've got about 6 tables in here that you're going to see, comparing the old code to the new code and looking at the changes. The other thing I want to do in this presentation is make sure and identify what I believe builders will use as the easy pathways to meet the new code. Some of it's pretty hard, and I don't expect many builders to do it. Some of it's going to be low-hanging fruit, and that's what I really want to focus on, because I think that's what we're going to see a lot of builders do. You can see here in most categories, the number of energy points required has nearly doubled. Small homes have gone from 1.5 to 3. Additions have tripled. Small additions. Multifamily went from 0 to 4.5. And we'll look at some case studies later on showing you how some builders are going to do this. The bigger builders that have long planning cycles have been thinking about this for over a year. And I've worked through them on a lot of code consulting to figure out the easy pathways to do it. So I've got some good real life case studies to share with you. So the first big change in our new code is what's called fuel normalization. And you can see heat pumps get you a positive point here, both single family and multifamily. There's a lot of similarities between single family and multifamily. There are some differences, so that's why I show both tracks here. The second strategy, which is one we've seen here in Washington for a long time, ductless heat pump 1-to-1, single zone system, largest living area, electric resistance everywhere else. We've had a lot of builders do that for about 10 years. Still a good pathway under the code. In single family, it'll get you a half point now. Multifamily, it doesn't get you anything under fuel normalization. You'll actually see later on in a couple slides that the high efficiency heating and cooling systems will get you points in a different category. Gas furnaces, fine to use. You'll see a couple slides later that the high efficiency gases can also score you points. Electric resistance is going to be a really hard pathway to go down. I don't think too many builders are going to be able to do it anymore. So one of the energy points options that is available for points under the new code is windows and insulation. If you go above code, U2.4 windows. Last I heard, the best double pane available is about U.25. I don't know if you can get a double pane 0.24. That might be a low end triple pane window. But the cost on triple pane windows is coming down. The cost on the really good double panes is coming down. So I think we're going to see some builders do that in both single family and multifamily. 2.0 windows, those are pretty expensive. I don't think we're going to see a lot of builders do that. The third and the fourth row here, 2.8 windows with some insulation upgrades and 2.5 windows with medium insulation upgrades. I think we're going to see some builders do that, particularly the second option here in multifamily where you have less windows in a lot of projects. This may be a cost-effective path. U2.2 windows with a lot of insulation upgrades, that's basically passive. I don't think we're going to see builders doing that. So this is where the new code energy points is really rich for using the high efficiency heat pumps and the mini split systems. If you do a good 9.5 HSPF central heat pump system here, you can get a point for that in single family. You don't get anything in multifamily. High efficiency 95% gas furnace, you can get a point for that. The third row here, ground source heat pump, it looks great, but I haven't seen any builders doing this in new construction for a long time. So in reality, I don't think we're going to see a lot of that. This fourth row here, mini split, 10 HSPF, largest living space, plus zonal electric everywhere else. Same as we've seen in Washington State for a long time. Single family, you get 1.5 points. Multifamily, you get 2 points. I think we're going to see a lot of this still in multifamily housing. Probably less in single family. And you'll see some examples of different pathways to get there in a little bit here. 11 HSPF heat pumps, you get 1.5 points here, plus you get the fuel normalization point. And you're going to see some examples of how this adds up if you go with heat pump system, and then you go with a high efficiency heat pump system or mini split system here. 10 HSPF mini split system covering the whole house gets you 2 points for single family, 3 points for multifamily. I think this is where things are going for multifamily. And we'll dive into some examples here on a couple more screens. Supplemental electric resistance is a little tricky. I'm sure there will be questions on this. I'm not going to answer them all, but I'm going to give you some general guidelines. I've had conversations with State of Washington on this. So here's a few things. There's a footnote buried in the code that says, if you're going with a central heat pump strategy, or if you're going with the all ductless mini split strategy, no more than 0.5 watt per square foot of supplemental. And where you typically saw that in the past was you'd have 1 or 2 bathrooms where people would put the toe kick heaters or the cadets or the whisper warms to provide supplemental heat in there. They're not saying no, you can't do it, but you can only use a little of it. So you might be able to do it in one room if you get a really small system. If you can imagine a 2,000 square foot house, it's kind of a higher end house, and somebody wants to put one of those tile underfloor electric warm mats, let's say it's 1,200 watts, that's not really going to be in the letter and the spirit of the new code. I'm not sure that'll get flagged all the time, but think about those little supplemental systems and how that's going to fit into the code. So this is another tricky bit. There have been questions on it, a lot of questions on this with the central heat pump systems. If you have a good heat pump system that meets the code, but you have a small gap for heating on the coldest days of the year at design temp, and you need a little strip heat kit, code says that's great. You can use supplemental strip heat kit, no problem. That is allowable under the code on the central heat pump system. There was a call about 2 months ago with the state where they said, can we also use a small supplemental system gas backup when it's really cold out? And the answer is yes, you can. I am not aware of any builders yet who found a cost-effective gas supplemental system that's less expensive than the strip heat supplemental. I don't think it's out there, but I could be proven wrong on that. One of the areas that I think confuses people a lot around the country, and certainly here in Washington State, is when you use a good cold climate heat pump system, you're probably not going to need strip heat. Good cold climate heat pumps now work well below 0 degrees. So if you design and we'll talk more about this a little later because it's a really important issue, but if you design a good system using a cold climate heat pump, you're either not going to need supplemental or you're going to need a very small amount of supplemental to close a gap. Supplemental heat in bathrooms, toe kicks, whisper warms, those radiant lamps are a little bit gray under the new code. If it's a straight up electric resistance system, then just follow footnote A. But imagine if you have one of those infrared lamps that you sometimes see in bathrooms. My understanding is that's considered a lamp and that's not going to be counted. Whenever you have questions on this kind of stuff, talk to your local jurisdiction and say, hey, here's what we want to do. Are you okay with that? And my understanding with most jurisdictions is if you are in the letter and the spirit of the code, you're going to be good, particularly if you ask questions on the smaller issues like that. But you should always ask. Okay, this is an area where there's a lot of opportunity and a bit of confusion here. You can get extra points under the new code for either moving your ductwork inside conditioned space or burying it deeply. And ducts inside conditioned space is an awesome strategy. I think over the next 10 years in IECC and other jurisdictions around the country, we're going to see everybody pushing for ducts inside conditioned space. In the last couple of years, there was some DOE research work done talking about buried ductwork. Buried ductwork is certainly significantly better than letting your ductwork go outside of the insulation. It is not as good as ductwork that's inside. So Washington State did a great job here saying, hey, you bury your ductwork, do a good job with that, we'll give you a half point. You bury it inside, we'll give you 1 point. I think it was a great scheme here. Multifamily, I'm a little confused on. The half point for ductwork deeply buried in ceiling insulation, I get that. I can actually envision some multifamily projects where you might use a horizontal ducted mini split system with all your ductwork inside conditioned space. And I don't know why you shouldn't qualify for 1 point. There may be a good reason for it, but I haven't found it yet. And I know there aren't yet many multifamily projects where they're doing horizontal ducted mini split systems. I think we're going to see a lot more under the new code. So that's something to ponder. I think we previously had this exception for 10 linear feet of return ductwork, 5 linear feet of supply ductwork. I've seen a little bit of confusion around here with some of the HVAC contractors on that. If jurisdictions are checking that carefully, some builders may need to make some adjustments. And you'll see, I've got some photos here of a case study for a builder a little later where you'll see some good examples of that.
Greg, real quick, can you define deeply buried?
Yes. So if you have attic insulation that's R50, which is, you know, your target attic insulation up there, they want all of that ductwork to lay on the ceiling joists and be all the way underneath that insulation blanket. I know historically we've had a lot of ductwork up above that. There's actually one jurisdiction in Washington I know that has said, hey, we don't like buried ductwork, don't do it, please. And I had a conversation with somebody at the state and I said, hey, can they do that under the new code? They're like, no, they shouldn't be doing that. So I think this is something all the jurisdictions, all the HVAC contractors and builders are going to need to work out. Buried ductwork is a good strategy if it's done right, not quite as good as ducts inside conditioned space. And if there's more questions on this when we get to Q&A at the end, I'm happy to talk about that. I've got some pictures of it. There's actually a really good DOE training video out there showing buried ductwork and how to do it right. Okay, moving on to improved air tightness and ventilation system here. If you want to go above code here and score some points, this is a possible strategy here. And I'm going to stop and talk about one builder I work with. I have a big builder here in Washington State that's been doing HRVs for a long time. They do a great job with it. So for this builder, they're actually going to keep using gas furnaces in some of their homes where they can get gas, keep using the HRV that's just going to get them points under the new code and just increase their air tightness of their homes. And that's how they're going to meet the new code. One thing that's really important, every builder has a little different strategy for how they build homes. And what will work easily for one builder to meet the new code probably isn't going to be the same strategy for the next builder because they all do things differently. So as you can see, a builder that's already doing HRVs, they may have an easy path to go down this table here. Okay, so 3ACH50 energy efficient whole home fan, I think that's pretty easy to hit. I think in single family, we'll see more builders doing that. I think in multifamily, we'll see a lot of builders going for this to get a point. The 2ACH50 air tightness and a 65% HRV is pretty easy to achieve. The third and fourth tier, 1.5 and 0.6, I don't think we're going to see a lot of builders doing. This expression here, sensible recovery efficiency, is just about the heat exchange efficiency. The other thing that you'll see in the next slide or two here is you also have to have an energy efficient fan motor on these. I am aware of an HRV that has a really good heat exchange efficiency, but has a not so efficient fan. So it looks good until you look deeper at the fan, which we'll talk more about in a minute here. So I really think these top two options we're going to see a lot of going forward in Washington State. The bottom two options, I doubt you'll see it. That very bottom option, 0.6 ACH50, guess what? That's passive house. So if you're building a passive certified home, you don't even need to go through this process. Some of you have probably seen this. If you haven't seen it, it's a great resource. HVI is the Home Ventilation Institute. It's kind of the industry standard, and they certify products, and you can track all of the efficiency here. So let's say if you're a building code official and you wanted to find out if somebody was putting in an HRV or an ERV that met the standard, this would be the place to look. It will tell you the SRE of every certified fan. It will also tell you the fan motor efficiency, which are the two things you need to look at. So this is a great resource. One quick comment on that. When I was doing Energy Star lighting, sometimes we'd run into products where they didn't get tested and listed. and they would just have the manufacturer's certificate. I don't know if that will be considered allowable or not, but these are things to watch out for if you see the HRVs and ERVs being used. So the residential code cross-references the commercial code here, and this is the minimum fan efficiency you need to have for these fans. And it's real important because if you have an HRV that's got decent but not great efficiency, and you have an energy hog fan in there, it's just not worth the money you spent on it in our climate. I've had this conversation with some people at NEA. So if you're going to get a good HRV or ERV or ventilation fan, make sure it's energy efficient. And Panasonic and all the others make great fans. It's easy to find a good fan motor, I guess I should say. So hot water systems under the new code. I'll kind of start from the top here and point out the options I think you're not going to see much and the options I think you're going to see a lot of. For homes that are going down the gas path, you'll probably see the third option here, the 0.91 efficiency, not the half. The drain waste heat recovery, I've seen one of those systems installed in Montana. They're beautiful if you know how to do it. I think I can count the number of plumbers in the Northwest who know how to properly install these on about 4 fingers. And that, yeah, it's just not a common system. They are great in the right application. I don't think we're going to see a lot of them out there. I think the low-hanging fruit under the new code is these heat pump hot water heaters. I think you're going to see a lot of builders using these to get points. You can get anywhere from 1.5 to 3 points, depending on single family, multifamily, which system you do. The NEA Tier 1 and NEA Tier 3, the cost differential on that from a good electric system is not a lot. I've got a lot of builders that are already using. The tricky bit with heat pump hot water heaters for a lot of builders is where do you put the system and what happens with that heat pump exhaust air. They're just like any other heat pump. They take air in from the ambient, hopefully outdoor air or buffer zone like a garage, and then they discharge air that they've taken the heat out of. So I love seeing these heat pump hot water heaters in garages. I think that's a great buffer space to put them in. If you don't enclose them in a mechanical room, then you don't necessarily need the ducting kit. It's not to say you couldn't use the ducting kit, but you don't need it. If you put one of these units inside a conditioned space, you are very likely required to put a ducting kit on there. They're easy to do, cost a couple $100. There's a lot of HVAC contractors and plumbers that are already doing it, but you should be mindful of it when you do it. What you don't want to do is put a heat pump hot water heater in a small closet under the stairs without the ducting kit, because it's going to discharge a lot of cold air and it's going to sort of counteract the heating in the house. It also actually will not qualify for the manufacturer's requirements for free airflow around that system. So you could put it under stairs if you had a proper ducting kit hooked up to it.
Craig, real quick on heat pump water heaters, yep. Matthias wanted to comment that there may be rebates available in some markets from the utilities for those.
That's about the third bullet point coming up on this slide. That's a great point. Yeah, I will just tell you that NEA in the Pacific Northwest has really been, to my knowledge, the leading pioneer on heat pump hot water heaters. They did a great job piloting them about 8, 9, 10 years ago, and it's become a mature technology that's ready for almost everywhere. We'll talk about that a little more here. NEEP and NEA, Northeast and Northwest, have also done a great job pioneering cold climate heat pump systems, which we'll talk about a little bit more in a few slides as well. A regular electric hot water heater can use approximately 18% of a home energy. Heat pump hot water heaters are like 3 to 5 times more efficient than that. So there you go, 60% energy savings over a standard electric hot water system. About $300 a year for the average homeowner. If you look at those little yellow energy efficiency stickers on those things, they're usually around $140 to $170 per year to run them. They're incredibly efficient. NIA calculated about $3,500 lifetime savings for each one of these. I've got a builder in Eastern Washington, big builder that gets good prices. I think their installed cost with the ducting kit is under $2,000 from their plumber. So these are great systems. Here it is, may qualify for utility rebates. There's a lot of utilities that do these rebates. May or may not be for residential new construction, but for retrofit applications, I think there's a lot of utility rebates around the Pacific Northwest. This is a kind of screenshot of the NIA qualified product list for heat pump hot water heaters. I think there's tier 1 through 4. One of the tiers has no products listed in it. So it's basically tier 1, 2, and 3. If you do a Google search, it's easy to find. So I think this is the last table that shows extra points you can get for energy code here. The state's now giving you points for doing solar. I think on single family, we're going to see more and more of this. Multifamily, I'm not sure, but it's coming. The Energy Star appliance package, I think for single family homes, that's a pretty expensive option to get a half point. Every builder, by the way, is going through this calculation and trying to say, okay, what's the most cost-effective path for me to meet the new code? And they're pricing all of this out. You're going to see some examples of this in a couple slides, but you know, if I pay $500 and I get 2 points, that's great. If I have to pay $5,000 and I only get 1 point, that may not be a great value for me. In multifamily, this Energy Star appliance package to get 1.5 points might be a good value. So we'll play with that in a couple case examples for multifamily here in a few slides. Gas fireplaces, there is some new code stuff on gas fireplaces. If it's a heat source, it's got to be better than 50% fuel efficiency. If your primary heating and cooling system in the house is central heat pump, mini splits, or anything like that, you really want to have something that has very low BTU output on it. If your heating system in your house relied on your fireplace for heat, that might mess with your fuel normalization credits. I think everybody gets that, but you don't want to see a 30,000 BTU heating system that people are relying on in winter for part of their heating load. That's not really in the spirit of the new code. Decorative fireplaces need to be properly labeled. There are some beautiful decorative fireplaces out there now that you don't necessarily need to hook up to the gas system. One of the problems in new homes with low heating loads is if I have a nice gas fireplace that puts out 15 or 20,000 BTU and I want to have a charming evening in the winter, I turn that thing on and after about 15 minutes, it's too hot in my living room. I either have to open a window or turn off the fireplace. So it's really important that the building industry, when you want a nice decorative fireplace, go for something that's as low BTU as possible, or maybe just get one that's designated as a decorative fireplace. So we're going to get into some case studies here. This is a big builder in Eastern Washington I've worked with for a long, long time. They have a net zero product line that they've built for a couple of years. I think it was 3 or 4 years ago, we did kind of a test project with them. And then we went through a few growing pains and things came around, and now we're helping them with all of their net zero product line. They kind of saw this as a test case for the new code. And about a year ago, we went and worked through all of their net zero homes to make sure they would get enough code points by using heat pumps and mini splits. Couple things to point out here. These are smaller homes. I think they're all 1,100, 1,200 feet. This is Spokane, where design temp is 9 degrees. But all of these homes, 18,000 BTU, 2 tons, 24,000 BTU, 21,000 BTU, and 18,000 BTU. So this is a great example where I was talking earlier about heating loads are coming down, even in the cold parts of our state. You can see all of these houses are 2 tons or less for heating loads. And the other thing that this builder did that was really smart is they said, hey, this floor plan lends itself well to using ductless systems. This floor plan lends itself well to using horizontal ducted systems. We actually, in 4 out of these 5 houses, have horizontal ducted systems here. You'll see some examples of that in a few more slides. One of the homes has a ductless wall head and a very small 1-ton multi-position air handler, sorry. We listed the HSPF here of all the equipment so we could calculate the points, and you can see these are less than 1,500 square foot homes. They need 3 points under the new code, and we were able to get it easily for them by using high efficiency heat pump systems here. And we vetted everyone out. There's one thing in here that's really interesting about how they did it that doesn't show without explanation. They had one floor plan that had a great room with a vaulted ceiling in it, and they could not figure out how to run the ductwork inside conditioned space out in that vaulted ceiling. But they said, we can do it buried ducts. So 2/3 of that duct system is ducts inside conditioned space. The last few supply lines that go out into the great room are buried ductwork. And we thought about it, and we basically said, well, you meet or exceed all of the buried duct requirements, even though 2/3 of it is ducts inside. So you should definitely get that half point for buried ductwork. So it's a really skillful strategy to utilize the new code and get the points. This is a very large national production builder. I worked with their verifier, a large national verifier, and they were doing this calculation for one of their builders. And you'll basically see here for heating, cooling, the easiest way they figured out, there's about 3 slides here. All of them are mini splits or high efficiency heat pumps to meet the new code here. And you can see some examples of how they calculated the credits. They may have had 1 or 2 gas options here. I don't think I grabbed those screenshots, but it was just easier for this builder to do with high efficiency heat pumps and mini split systems. And every builder is doing a calculation like this right now. And so we all need to work together and try and make it as easy as possible. Okay. This slide I put together a couple days ago here. Most of my builders are single family, but I'm doing more and more multifamily work now. And I knew for this call, we have quite a few building inspectors on the call. We would want to talk about multifamily. One of the important things on the new code is the code says you have to get so many points. They don't tell you how to get them. You can do it any way you want as long as you get enough points. And every builder is playing around with this and trying to figure out what's the easiest, cheapest way to get there. I listed in the left column here all the different opportunities builders have to get points and what they're worth from the multifamily tables. The 3 that are light orange on top, example 3, example 5, and example 6 are gas pack. And I'm gonna break some of these down for you. It is actually my belief that example 4 is gonna be the cheapest and easiest way for many multifamily builders to hit the new code. And that is gonna be single mini split plus electric resistance in all the smaller rooms and the NEA tier, I think it's tier 2 heat pump hot water heater. The tier 1 and tier 2 heat pump hot water heaters, very affordable. The only trick for a multifamily builder here is where are they gonna put that unit? If they can put it in a closet out on a deck so that the exhaust air can flow outside, that's awesome. I have a builder over in Spokane that did a multifamily project, and they created a little mechanical loft on every floor that has louvered opening to outdoor air. So you see things more like that.
One other comment on is that with heat pump water heaters, one comment is that you can duct them. So you can duct air in or duct air out. Right,
right. Yeah, ducting is easy to do. It adds a little bit of cost and complexity. So wherever you can avoid it, it's great, but sometimes it's the right way to go. And we're seeing more and more of those ducting kits out there. So I think we're gonna see a lot of these in multifamily for sure. The other thing on multifamily, remember, is it doesn't matter if it's a 200 square foot micro suite or a 5,000 square foot luxury penthouse apartment, you need 4.5 points. That's kind of a big difference between the single family code where it's small, medium, and large homes. Example 1 here is another one that I think is going to be relatively cheap and easy for builders. Do the 10 HSPF mini split system in every part of the unit. Then you'll get 1 point for fuel normalization, so that's 4 of your 4.5 points. And there's 2 options here for a half point. I just picked upgraded windows. Small apartments, to upgrade your windows isn't going to be a big expense. And if you think about a studio or a 1-bed where you might just use a ductless wall head for the whole unit, this would be an easy option to do. For the gas path here, if you look at example 5, upgrade the windows to U 0.24, and then you can take like 2 ACH50 HRV. That's not too hard to get to, particularly in multifamily. High efficiency gas furnace, high efficiency gas hot water, and you can get there. So these are just examples. And you can see in example 3 here, I put in the Energy Star appliance package. I think in multifamily, we're gonna see more of that. It's not necessarily the cheapest option. And let's talk about that Energy Star appliance package. It's your dishwasher, your refrigerator, your clothes washer, and your clothes dryer must be Energy Star appliances. That clothes dryer must be an Energy Star ventless dryer. Those are a little expensive. So if you're providing all of those appliances in the apartment, making that upgrade is going to be pretty easy. Some apartments, many apartment complexes have central laundry. And I do believe that was a question raised to the state of Washington about 4 or 5 months ago is, well, what if it's a multifamily project with central laundry, but we're putting in Energy Star washers and Energy Star ventless dryers? Can we still get that point? And I believe the state's response was jurisdictions, provided it's in the letter and the spirit of the code, can make those kind of exceptions. And we're going to see more requests for clarification from the state here on some of these issues. I think ductwork and multifamily, buried and inside conditioned space will be one of them. If you look at my left column here, I've got some highlighted items that I wanted to kind of point out that I think there's a little bit of ambiguity or grayness on that I suspect we'll see people seek clarification on. I talked about ductwork deeply buried under the multifamily path. You can get a half point for that. Why they didn't offer it up for ducts inside conditioned space, I'm not clear. I feel like we're going to see projects where they use horizontal ducted systems, all ducts inside conditioned space, and they may want to go for those points. We'll see. Hot water is really ambiguous because a lot of the multifamily projects, we're seeing semi-centralized and centralized hot water systems. We are seeing some of the air to water heat pumps go in for those central hot water systems that probably meet this efficiency requirement. I suspect it won't be long before the state gets a question saying, hey, if we have a central or semi-central hot water system that's high efficiency, can the builder get these points? Good. Lot to think about on multifamily. I think these are pretty good examples of how many multifamily builders will get there. One thing, I've got a multifamily builder doing a project in Shelton, Washington, and I think PTACs are going to be endangered in Washington State for multifamily projects. So there just aren't a lot of PTACs that meet the minimum requirements. So I think what you're going to see is builders go to lower tier ductless heat pumps in the large living area and electric resistance in the bedrooms, probably for all the multifamily projects. I say this almost every presentation I'm in. The state has an okay worksheet that's a block load. It's a good starting point, but you really, really need to do room by room heating and cooling load counts for every project to do this right, particularly when the loads are coming down lower and lower. because distribution is really the challenge. Once you have a good heating, cooling load count, pick the right size system. That builder in Eastern Washington that I showed the 5 different net zero ready homes on is a great example of that. You just need 1.5 ton or 2 ton systems for every house. And I have seen HVAC mechanical engineers and HVAC contractors add big safety margins in with heat pumps. They don't need to. And you end up getting an oversized system. And we really broke this down with one of my builders. And it turns out that safety margin was costing about $1,500 or $2,000 on every house. And we said to the builder, hey, if you do good load counts, good HVAC design, you can save money on every house. And so we really changed things and we were able to save that builder money. As loads keep coming down, it's all about finding good distribution solutions. So these small horizontal ducteds that you'll see some case studies on here and pictures really work well for good distribution to cover a couple different rooms where you have, heating load of 3,000 or 4,000, cooling load of 1,000 or 2,000. I don't know if any of you have ever seen projects where they do a big multi-zone mini split system and put a head in every room. It's almost always a very bad strategy, and that's what we want to avoid. When you really look at these room by room load counts, you can start to do good design, and you just need 2 or 3 small systems in each house. So I've shared this with a lot of people at HVAC distributors, builders, HVAC contractors use this all the time. This is my cheat sheet for our central high efficiency heat pumps to meet the new Washington State code. Lots of other manufacturers have good equipment similar to this. And there's a lot of things that I want to point out in here. The first is, you can see when you use good variable capacity heat pump systems, you can get different size systems to fit every load for a house. They come as small as 6,000 BTU. That's smaller than most homes need, although there are apartments and ADUs where 6,000 BTU is about right, all the way up to 3.5, and there are some 4-ton systems out there too that I didn't list here for residential applications. So with variable capacity heat pumps, it's easy to get right-sized equipment. Super important. The other thing that's super important is there's, in broad terms, 2 flavors of variable capacity heat pumps. Standard equipment, which generally speaking is for temperatures, winter design temps of about 30 and above, and then cold climate heat pumps that are for winter design temps below 30. Things have been getting blurrier in the last few years. Even standard heat pumps are doing better in the cold. So in Seattle and Portland, I sometimes see standard heat pumps being a good choice. And sometimes they cover 90–95% of the load on the coldest day of the year. So you get a smaller system and you put a small strip heat kit on there. It only comes on a couple days a year. I've got a builder down in Portland that's been doing exactly that for the last 2 years. When the polar vortex hit about a month ago, we had a few homes get a little cold, and we're going through a redesign process with some new equipment now. And you can see here, all of the green ones here get you 2.5 points before you look at the ductwork bonus points. You can get up to an extra point for ductwork. So by using a high efficiency central heat pump, you can get anywhere from 1 to 3.5 points, depending on how you do it. Over in Eastern Washington, you almost always need cold climate heat pump equipment. There are more and more of them out there, and you should work with an HVAC contractor that's good with this design. If your HVAC contractor needs help, they can always go to their manufacturer for good design with cold climate heat pump systems. So I think we've got 3 case studies left here. This is a builder down in the Portland area we've worked with for a long time. They were building Earth Advantage 3-star homes. Earth Advantage is a program that's very similar to Washington State Built Green. They were using gas furnaces and gas hot water systems in there. And about 2.5 years ago, they went to Earth Advantage and said, hey, we want to start using solar and push for net zero. And as soon as they started to push for solar and net zero ready, they realized that switching to an all-electric heat pump system was a good choice. So you're going to see how that looks. And they still do gas tankless hot water heaters in these homes. So this is our high efficiency central heat pump. It was plug and play where they had a gas furnace before. And I'll show you some more examples of that. This is in downflow configuration here. It's a multi-position air handler, provides heating and cooling. And then, well, let's get to the next slide here, because one more of the air handler here. Here you go. They're using open web trusses between the first and the second floor. And so all of a sudden they've got ducts in conditioned space. Super easy, minimal cost for this builder to make the change. So all of a sudden they have a net zero ready, nearly all electric home with ducts in conditioned space. One bonus, I think we're going to see more and more builders moving to this strategy. I've got quite a few builders that are already doing it to meet the new code. But when you move to these open web trusses, all of your mechanical trades find it easier to work on the home. You know, running wires, running pipes, running ductwork, just easier through open web trusses. The other thing somebody told me about this is when you use open web trusses, it's easier to get open spans in rooms, which is kind of a cool bonus. More shots of some really good ductwork. This builder uses the best possible insulation they can get in the walls. They have really low loads. These are like 2,000, 3,000 square foot homes, and they're using 2.5 and 3 ton high efficiency central heat pumps, and all of them with ducts inside conditioned space. Really great design. So this is the return air, and it's kind of interesting because you can have your return air run outside of conditioned space. This particular jurisdiction asks people to go above and beyond that. So they build this box and put the insulation around it. So this is pretty close to what you would call buried ductwork, except they built the box around it here. And so that brings the entire duct system inside of conditioned space. And you can see these solar panels on the back of this house here. There's a certificate from Earth Advantage inside this house. I think it says their estimated energy bills for this house are $9 a month. And that's primarily the gas hookup charge and whatever gas they use for the hot water system. It's framing. Okay. I have worked with Habitat Tacoma for a long, long time, since back in my Energy Star lighting days. They are a fantastic builder. They build incredibly energy efficient homes. They are willing to test new stuff. They've been one of the great guinea pigs here in Washington State. It was probably 2010 or 11. Somebody from Tacoma Power went to them and said, hey, will you do a monitored heat pump test for us on ductless heat pump systems? And Habitat Tacoma said, sure, we'll try this for you. So they did, I think it was about 10 homes where they put in a ductless wall head in the large living area. And then they did electric resistance in all the small rooms. They also put a redundant electric resistance in the great room. 1 week they would run the heat pump and turn off the electric resistance in the great room. The next week they would run only electric resistance. So their base cases were identical in their home. They didn't have to compare one home to the one next door. They proved that they got about 50% energy savings on these homes. Tacoma Power and Habitat went to the state when they were doing a code cycle, probably 2012, said, hey, there's so much energy savings opportunity here. Can we write this into the next code? So in Washington State, the code path you've seen where you have the ductless mini split in the large room, plus electric resistance in all the small rooms, this is where it came from. And we work with them today and they do great stuff and they're still fun to test stuff with. And once in a while they have a few growing pains, but 99% of the time it works awesome.
Greg, just a time check. You have about 5 minutes left before the
Okay. Yep. I'll move quickly here. Thanks. Couple quick things to point out here. 2 1-to-1 systems here, very small independent systems. Get better turn down ratios. And these are the horizontal ducteds we were talking about before. That's probably a 12,000 BTU horizontal ducted on the left slide there. That's the supply into the bedroom. So you have a small horizontal ducted system supplying 3 or 4 bedrooms down this bedroom corridor here. And this strategy with this compact duct design works great. Circulates around the whole room, eliminates a lot of ductwork so you can value engineer. You can see that's the return air side there that's closed up during construction to keep the dust out of there. There's the wall head in the large living area. I want to get to their second one here. I'll back up here. That's what it looks like when it gets finished off on the right slide there. That's a horizontal ducted system going down the bedroom corridor and a soffit ceiling. They continue to make some improvements on this system here. This is a horizontal ducted system with the return air coming down the back of the corridor. The gentleman you see in shorts there is one of my favorite HVAC contractors. He's not afraid of trying stuff. You're going to actually see up there the supply ducts into this bedroom are Unico high velocity duct systems. We do not endorse that application with our system. We have medium static air handlers. Those little terminations are designed for high velocity. The reason it works here is the whole load on this house is probably 17, 18,000 BTU. Each of these bedrooms is probably 1,500, 2,000 BTU max heating load. You don't need a lot of heating and cooling to keep it comfortable in there. That is the horizontal ducted smart, I call it a smart duct system here. That is about 5 inches high, about 18 or 20 inches wide, hard pipe in a soffit ceiling there. So you're losing about 6 or 7 inches of ceiling, and then you've got these small little branches going into each of the bedrooms here. It's a fantastic design. This builder's actually going to flip that around, and so they're going to have one horizontal ducted now serving the whole house. So they've really value engineered it with variable capacity heat pump systems. They put an HRV in, they have for a long time. They believe in good indoor air quality. That'll get them points under the new code. That's what the terminations look like when they're finished off. Again, we don't endorse those Unico plug and play systems. That is the return air at the end of the hallway with that little box coming down. Last example here, and we will be done right on schedule. This is a great builder out east, and they worked with their truss manufacturer and said, hey, we want to use a horizontal ducted system here to serve all our bedrooms upstairs. And the truss manufacturer said, no problem. The cost to do this was about $300, the builder said, to put this little box up here so they can keep all the ductwork inside conditioned space. And they're utilizing this horizontal ducted system for all their upstairs bedrooms. And that's what it looks like finished off. Little tiny horizontal ducted air handler. The grill you see there is the return air. And then that's the access panel in case they ever need to do any service or maintenance work on it there. Great application of a horizontal ducted system. I really believe as people catch on with the new code and figure out how to design to the lower heating and cooling loads, we're going to see a lot more of these horizontal ducted systems. We made it right on schedule. Thanks for the time check, Ken. That kept me going right on track.
So I think one quick question that came up that we didn't really address in the chat was the 2018 WSEC, will it still allow sizing to 125% of heating load?
I believe that's an ASHRAE-ACA thing, and I don't want to give a definitive answer here. I would have to double check in the code book, but this really gets back into good HVAC design. You don't want to oversize systems, even if they're you don't want grossly oversized systems, even if they're variable capacity. You will increase your energy use. You may have short cycling, which will have an impact on comfort. And if anybody wants to have those conversations about good HVAC design, turn down ratios, and right sizing systems, I love to have those conversations. Shoot me an email or give me a call and we can talk.
Okay, and we have a question from Chris, or his hand is raised, Chris Kitsky, and I just unmuted you, Chris, if you want to ask your question. Or maybe we lost him. Let me check here. Yeah, I think he might have just dropped off, unfortunately. I'm going to unmute John Bushnell. John, did you have a question? Oops, you're self-muted.
There, am I unmuted?
There you go, John. We can hear you.
We can hear you.
I'm sorry. Go ahead. Yeah, as you were going through the PowerPoint there, I saw you mention the Sanyo. Or I was wondering, do you know much about that system? Oops, let me turn this off. Being used to supply heat for radiant slabs.
You're talking about the sand end, correct?
Oh, I'm sorry. Sand end, right?
Yeah.
One of the models
I actually worked on sand end test sites up here in Washington in the Northwest. I know a fair amount about the sand end systems. That's kind of a longer and more complex conversation. Are you okay if we just hang out later and talk, or do you want to give me a call later and we can talk about that? I can probably help you out.
Sure, I'd like to get as much information as I can on it.
They're good systems and I like them.
What's that?
They're good systems and I like them, but it's a detailed conversation that may not have broad appeal. So let's talk offline on that and I'll try and help you with it.
All right, sounds good.
Yep. The other thing that I wanted to mention is if you're interested in getting a copy of this presentation, you can email me and we'll be able to provide that.
All right. I wanted to thank everybody for joining us today. Again, this is Jonathan with the Home Builders Association in the Tri-Cities. Look forward to hopefully seeing you in more of our lunch and learns that are coming out in the future. I just wanted to give an ending point here for those who need to continue about their day. We decided we'd hang on here for a little bit longer to answer some questions for those who wish to stick around, but we wanted to try to honor that 1 hour timeline because I know that we're all very busy people. So if you do have some questions, please stick around for a few minutes. Otherwise, thank you for attending, and it is very much appreciated, and good luck out there.
Are there any other questions out there people want to ask? I see people disappearing. Thank you, everybody. Oh, go ahead.
There's a few that just popped up in the question boxes. Let me see if I can cruise through them real fast.
Yeah, go ahead. I don't have the question box open. Go ahead.
Transfer grills used at bedrooms?
Yes.
I think it's a paraphrased question.
So there's two kinds of transfer grills. Transfer grills can be for pressure relief in the ductwork system. Is that what you're referring to, or is it transfer fans to move heating and cooling around the house?
This was from Kevin. Is Kevin muted? Can we unmute him?
Yeah, Greg, this is Kevin with Snowputt.
Hey, Kevin, how are you?
Good. I just saw one of the pictures you had for the ducts inside. It looked like they just had pressure transfer grills at the headers above the doors for the bedrooms. Is that what they were using?
So I'm not sure which picture you're referring to, but in general, what I can tell you is larger rooms need transfer grills for pressure relief or significant door undercuts. A lot of my builders, if they're not putting carpet in for large master bedroom suites, will do one of those little transfer systems, either a transfer grill or that short duct that passes over the top for pressure relief. And then on small bedrooms, a lot of builders are fine doing door undercuts. Sometimes local jurisdictions have something to say about that. I haven't seen any pushback in Washington on door undercuts. It's out in Idaho. Sometimes there's pushback.
Okay, thanks.
Yep, thanks for coming, Kevin. Any other questions?
John has a couple questions for remodeling and whatnot. I'm not certain if he's still on here. Are you available, John? All right. I think that pretty much clears up the question box then.
Oh, I'm sorry. I had my microphone muted.
Oh, there we go.
Quick question. I'm running into pushback on renovations, remodels, additions. In
Right.
that the 2018 code, they want to paint it with a broad brush across the whole project, which often doesn't work if we're doing a small addition and say
Right.
renovating an interior, converting uninhabited space or unheated space to heated space. And so I had to deal with the people that wrote the code in order to try and figure out how best to deal with these points, because the building departments, they're not very well educated or versed in the energy code and what it means and the ramifications. They can only spit out and reiterate what they think the code is asking for. So on renovations and additions, I run into some issues. I mean, I love the ducted mini split, and I think we specified the Mitsubishi version because it looks like the best one out there. I had a question personally because of mixed systems. You know, half the house might have an old heating system, electric resistant heating, which we get dinged for -1 point. And then, you know, sometimes gas heating systems. So that's what I'm going to experience the most challenges with the building department are these mixed systems in terms of just installing one of these mini splits, a single one, I guess, for the new space and ignoring everything else, which, you know, raises my hackles because, you know,
Understandable.
we're dealing with a leaky home to begin with, and we're having to treat the new addition as though it's super tight, which is silly because they're open to each other. So how do these systems hold up or work when you've got it installed in or you're looking at putting it inside a system where you've got maybe not a complete separation between these spaces?
Yeah, I think there's two questions in there I want to try and tackle. The first question is, and Jonathan from HBA Tri-Cities and I were talking about this before the call, maybe it was a day or two ago, the remodel points required, I think it's 1.5 points for additions under 500 square feet, can be pretty complicated. And as I think about that, I think there are a lot of small renovation projects, additions, where that may be hard to achieve. So everyone's going to be a little different. I feel your pain on that. What I can tell you is for added space, you know, like a ductless wall head system might be the easy way to heat and cool that. A lot of times we see where there's spot comfort problems or small additions, we'll see people use the ductless mini split systems. Great solution for that. Whether or not it gets you all the code points you need is out of our wheelhouse, so to speak. I think there's going to be a lot of renovation projects, the small ones, where people are going to struggle with this, and I don't know how the state and the local building departments are going to tackle it. It'll be interesting to watch.
Oh, okay. So that's what I was afraid of. You know, it's a case by case situation, and I think my main concern is that, you know, most people just want to extend their existing gas appliance out there, and that seems to be working against us with this those negative points. The main issue I have is how do these systems work, like the ducted mini split inside of larger spaces that are also.
Yeah, two thoughts for you on that. The first is, if you're doing a 500 square foot addition to a house and you're trying to just use the existing system to heat and cool that system may not be appropriately designed for that. So I would be careful of that. But here's another really good possibility for you. Let's say the house has a 3-ton system in it now, and it's a gas furnace. Maybe with, here in the Northwest, we have a lot of older houses where you don't have air conditioning, but
Right.
more and more homeowners want to get air conditioning. I've done quite a few remodel projects here in the Northwest, Portland, Seattle area, where people are like, hey, I'd like to get some air conditioning in my house and use an energy efficient system. So we take out the old system and just drop in a high efficiency heat pump. And if the ductwork is reasonably good, then you can just plug and play it right in there. It can be a great retrofit project. And that may actually help you get all these code points you need to get where you need to be for these small renovations.
So that falls under the heat pump fuel normalization description. Is that right?
Here's my understanding of renovations, and I'm not going to claim to be an expert on this, but generally speaking, if you add 500 new square feet to a house, all of that should be built to the current code. If you don't touch the rest of the house, you don't have to do anything to it. I can't imagine jurisdictions in the state saying, hey, you're going to do a 500 square foot addition to your house, but we want you to do a bunch of other work to the existing part of the house. I don't know.
No, they do this, the fuel normalization description. For example, if we are trying to extend the heating system, it's under heating option number 5. All other heating systems is a minus -1 credit. So I've gone from 1.5 credits I need now to 2.5. And so the fuel normalization credit was set up.
I'm going to go back to that slide here. We're getting into the weeds on this, and there's still a bunch of people on here, but I suspect this is going to affect a lot of people. So I'm okay talking about this. I love talking about this stuff. I want to get to that slide. It's early on here. Here it is. I'm going to pull up my screen so I can see it. But I don't think they can ding you for all of the existing stuff if you don't touch it. I think your heating and cooling that you put in the new part of the house needs to meet the new code. Now, if you're trying to extend the existing system, I can see how that would be complicated.
Okay, great.
If you add a ductless mini split in there, though, you might get 1 point for fuel normalization, and you might get a couple points for the ductless head in there. So that might meet all the points you need.
Hey, Greg.
Yeah.
I was going to mention that in the comments, Patricia wrote that she's with the City of Vancouver and has the same concerns with small additions or renovations. So along with her local TAG group, she'll be asking for an opinion from the SBCC. WSU is very helpful on that.
Yep. The people I talk to at WSU are awesome. And these I call them the gray areas in the new code. And we always have a few gray spots and ambiguous stuff. We just need clarifications on. And I think the renovations, small renovations, is definitely going to be an area where we need guidance. So, if the Vancouver building department asks it, that'll be great.
That would be. I wish all the building departments asked it, because they just tend to quote other things that they're not real familiar with. So the rest of them are on the same page.
Yep. And when the building departments aren't sure, they go to the state and say, hey, we need guidance here, and then they give you good guidance.
Okay. I like your optimism. Thank you, Greg.
They're reasonable people. They'll give you they'll help you. Any other questions?
I don't see anything in the chat box.
Well, those were good questions. I appreciate everybody coming. I think my email and phone number are up on that last slide. I'll zip down to it and leave it up on screen for a couple minutes. But you're welcome to reach out to me or Jonathan if you have questions, and I'd like to help you out. I'll get it up on screen here. So my contact information is there. It's coming. Fast as my clicker can go here. Thank you, everybody. I'll put contact information on screen.
I think it was your last slide.
It was your last
Greg.
slide, Greg.
Yeah, I'm working on it. It's coming.
There you go.
There you go. Thanks, everybody.
Thank you, everyone, for joining. Thank you, Jonathan, for hosting.
I'm going to mute it and leave this up for a minute or two in case anybody needs to get it.